Here in Lesson 5b, we're going to learn a little bit about variable scope within functions, why some variables look like they have a different value inside a function, outside a function, and so on. So let's get started with this. Okay, the scope of the names of parameters that are passed into a function is only the block of code that defines the function. So let's take a look at this example. X equals the list 7, -3, 5. So I've got a variable called x. It's type list, has a length of 3. I now define a function called printMax, giving it a parameter called inputList. That says there's going to be an indented block of code that I'm going to associate with the name of the function printMax, and it's going to have a parameter called inputList that is only defined inside that indented block of code. So inputList is not a variable that lives anywhere else. Whenever I call printMax, whatever I send in as the first value gets bound to or associated with the name inputList. What does this function do? It's pretty simple. All it does is print out the maximum value of inputList. So let's see what happens. I've got x is my list. I define the function. Now I'm going to call it by saying printMax, passing it x. What does this do? It runs this function. Function has one parameter called inputList. The first value I'm passing in is x, so inputList now has a list that contains 7, -3, and 5. Prints out the maximum one of these, which is going to be the number 7. If I now try to print out inputList, this statement right here will fail because inputList is not defined in my main program. It was only defined inside this function right here. If I do print x, that's going to work just fine. That's going to print out the 7, -3, and 5. Now I can reuse variable names if I want. Let's say I've defined x equal to 5. That's in my main program. Then I'd say I'm going to define a function called myFun that takes a parameter called x. Inside the function, whatever you passed in as x, I'm going to add 1 to, and then print it out. If I do myFun x, that's going to take my value 5, pass it in here, associate it with the letter x that's only defined inside this scope, add 1 to it, so it now, this copy of x now has a value of 6. I print it out, I get the number 6. So I'm done with that statement. If I now say print x, what gets printed out is a 5. I get a 6 first, then a 5. Now why did that happen? Let's take a look at how Python handles memory. I'm going to draw a few diagrams here. Let's assume that in my main program, I've got a bunch of memory allocated, and there's going to be a value called x. Python says, okay, I'll give you enough room to store an integer because you said x equals 5, and I'll put the value 5 in here. This memory is available the entire time I'm running my main program. Now I say define myFun with a parameter of x, add 1 to x, print it out. This is my definition of myFun. And Python says, okay, whenever you execute it, I'm going to set up some memory that's going to be used just by the myFun function. Oh, it's got a parameter called x. I better leave room for something called x. Don't know what's going to go in it yet till you call it, but I'm going to know I need some room for it. Now, when you get to this statement right here, and you do myFun of x, it'll activate this memory right over here. It'll say, yep, you've got a myFun function running. I'll give you some memory for it. Oh, take whatever's in x in my main program, that's a 5, put it into the first parameter of myFun. First parameter there is called x. All right, I'll put a value of 5 in. It passes the values by value, not by reference. This is a different copy of x than this original one. It runs the program, adds 1 to it, okay. This one now has a value of 6. Prints it out, prints out a value of 6. Now, My function is done. This memory goes away. Gets returned to the operating system, no longer used. I'm back in my main program. I print out x. Oh, x is 5. That number gets printed out right there. There's absolutely no remembering what happened in the function, because that function, once it closes, all of its memory goes away. So let's look at another example. Here's my main program again. In my main program, I have something called x. It's got a value of 5. In my function, my fun, I'm going to have my first parameter is going to be called a. And whenever I run this, I will give myself some memory. It's got to have room for a. I'll add 1 to it printed out. So now I call my fun x. All right, my frame of memory for my fun gets activated. I'm passing in x. Okay, x is this value. Go into the first parameter. Oh, that's what I'm calling a. I'll put a 5 in here. Now, a inside my fun has a value of 5. If there were an a in the main program, I could have had, say, a over here equaled a, b, c, d, e. I'd have something here that says a, b, c, d, e. Doesn't matter. Inside my fun, a is this a. A equals a plus 1. That changes to a 6. I print it out. 6 gets printed out. My fun is finished executing. This goes away. Now I print x. I print out a 5. If I were also going to print a at this point, I would get a, b, c, d, e. You getting this? You understanding the scope? Well, let's make it a little bit more complicated. What happens if we have more complicated data? Data that is going to be something that's iterable, like a list, or something more complicated, like objects that we haven't done yet. Here's my main program. In my main program, I've got something called x. Oh, it's a list. It might be growing. It might be getting bigger. It's got 3 elements now, but I don't know how much memory to give it. So I'm going to put it down here. I'm going to have a 5, a 6, a 7. And if I need to append more items, I will. What gets stored in my main program? A pointer to where this is. A pointer, the address of where this list is stored. Now, when I do my fun x, when I define it, I'm going to have some memory for my function. It knows it's going to have an initial parameter. Doesn't know how big it is yet, because it doesn't, until you call it, it doesn't know if x is going to be a list or an integer or a float or anything else. Oh, I'm going to change the value in position 1 to 0, print out the entire value of x. Okay? My fun x, when I execute this line, I will create the memory for my fun, x. I'll pass in x. What is x? A pointer to that list. And it's going to go into whatever the first parameter is. That's also called x. So this value goes in here, a pointer to down there. X square bracket 1 equals 0. Okay, x. Oh, that's a pointer to a list. Here's x sub 0. Here's x sub 1. Oh, I'm going to change that value to 0. My list now contains 507. Print it out. What gets printed out? 507. I think it prints it with commas. Now, I'm done with my fun. This goes away. The memory goes away. Notice the place where I've got the list didn't go away because somebody's still pointing to it. Now when I print x from the main program, it'll print out 507. I can't change a value inside a function that I call, but I can mutate it. X is the list. I can't change that, but I can mutate the list, meaning parts of the list can have their values changed. That's an important thing to remember when we're working with functions. Now, one more item and then we'll be done. There's a keyword in Python called global, which says, hey, instead of making me a local copy of X, make this something that's from my main program. I don't want my own private copy that comes and goes when you call the function. I want to use a global value. So let's see what happens. Here's my main program's memory. And I'm going to put a 6 in for X. Now, whenever I define my function, it doesn't take any parameters, okay? Might need some memory for something else. This is what the memory for my function would look like. No parameters. Oh, global X. I'm not going to put an X over here. Whenever I use X, it's going to take the global definition, meaning go back to the main program. Add 1 to it and so on. So what's going to happen? When I do my fun X, this memory gets activated. I go in here, global X. Okay, X is really here. It's not in here. No, I don't have an X over there. My X is this one in the main program. Add 1 to it. Changes its value to 7. I'm done with my fun. Its memory goes away. Notice X still has the changed value. When I print X, what gets printed out? The number 7. Now, that looks like it might solve all your problems of not understanding scope of variables. But it's dangerous. Warning, do not use global too much. Be very careful about using the global keyword. In a very small program, it's okay, because you're going to understand what you're doing, what all your variables are. But in general, it's very dangerous for a function to make a variable global. If you do, when you call the function, it can change a value used in another part of your program that you never even thought might be affected. Your program might be several hundred lines long. You might be using 20, 30, 40 variables. If you put something in a function that said global X and you use an X later on, you've just affected a later on part of your program without even knowing you were doing it. That's called a side effect of a program. It's something that you didn't intend, but it still happens. It's usually best to avoid using global. Have your functions only interact with values that you explicitly pass in as parameters. Or, in our next lesson, we'll learn about classes, which could give you a better alternative. Happy programming!